This is a hint for 3.2.1d. So we're asked to find the probability that x is greater than or equal to 8. Well, this is a geometric distribution, which is how many times you have to do something before you get your first success. So this could be the probability that x equals 8, or the probability that x equals 9, or the probability that x equals 10. But you have to keep going. And even though your numbers are technically getting smaller and smaller, theoretically, you could also have the probability that x equals 100. And you could have the probability that x equals 1000. Now, you're not going to want to find all of those probabilities. So let's use the complement rule. But the problem is, you have to figure out what is the complement of x greater than or equal to 8. People often mess up on that, so I like to write out the list of possibilities. So x can possibly be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, Okay. It's your first success, so 0 is not included. So for up above, we have the probability that x is greater than or equal to 8. So that's that. So what is left? So then what's left? So our complement is going to be the probability that x is less than or equal to 7. Notice we had greater than or equal to 8. Here I do less than or equal to 7. I could have written just less than 8, but the reason I want less than or equal to is that's going to be my CDF. This whole thing is the definition of your CDF. So this is just going to be equal to the CDF at x equals 7. And it's a lot easier to plug it into the CDF than it is to find all 7 of those probabilities. So the probability that x is greater than or equal to 8 is going to be equal to 1 minus the probability that x is less than or equal to 7. And again, remember that's just our CDF at x equals 7.